Hey sixth graders, we are going to take everything that we've learned so far about the area of some of our basic polygons like parallelograms, rectangles, squares, triangles, trapezoids, and circles, and we are going to start applying that knowledge to be able to find the area of what we call composite figures. And a composite figure is a figure that is made up of or composed of, and as you can see, that's the stem of the word, composed of two or more two-dimensional figures. To figure out the area of composite figures, we can decompose the figure into polygons that we already know and love. And yes, I'm sure you're starting to love these shapes. So decompose means to break down. Like if you think about, like a compost pile will eventually decompose. And so decompose means to break down. So we can write that down. So we're gonna break down the shapes into the smaller shapes. And what we're gonna do is we're gonna find the areas of those smaller shapes and then combine them back together. And what operation deals with combining things? Addition. Your organizing your work is going to be really important for this because if you don't, it's going to be hard to keep track of all of these different areas. So please make sure you follow the method that I use. So in general, this is just some review of the formulas we will be using. So some of the common shapes you're going to see are going to be rectangles, parallelograms, triangles, and trapezoids. So remember, a rectangle is length times width. Parallelogram is the base times the height, where the base and the height have to be perpendicular. That's the perpendicular sign, where they have to make a right angle. The area of a triangle is 1/2 times base times height, when yet again, your base and your height must be perpendicular. They must make a right angle with one another. And the area of the trapezoid is 1/2 times the height times the sum of the bases, which are those two parallel sides. So let's jump into an example. So we are going to figure out the area of this house-looking shape. And what I see is a rectangle, and I'm going to outline that in purple. And I also see a triangle. And in fact, some of you might be saying, well, I see two triangles. That's true. And you could actually tackle this by finding the area of the two separate triangles. However, I'm going to see this as one big triangle just to eliminate a step. So what we need to do is we need to break up the composite figure into shapes we already know and love and compute. Oh, sorry, wrong blank. I apologize. And then what we're going to do is add the areas together. Sorry, we're going to find the sum of the areas, and that will be the area of the entire shape. So let's start with the rectangle. Again, I want to see your trifecta. I want to see the formula first. So the area of a rectangle is length times width. Then I want to see you substitute. So we have 12 yards times 10 yards. And then lastly, your answer with units. 12 times 10 is 120. Yards times yards give you square yards, yards to the second power. So the area of this rectangle is 120 square yards. So that's not the entire shape quite yet. That's just the area of the rectangle. So now I'm going to find the area of the triangle. So I'm going to use this space over here, and I'm labeling which shape I'm finding. So this is the area of the triangle. Formula is 1/2 times base times height. Now I see that 5 is perpendicular to this unknown base here, but what we know about rectangles is the opposite sides are congruent or equal. So if it's 10 down here, that is going to be 10 yards up here. So this is going to be 1/2 times the base of 10 yards times 5 yards. And now we solve. Half of 10 is 5, and 5 times 5 is 25. Yards times yards gives you square yards. I'm not finished yet. So the area of the triangle is 25 square yards. So what we need to figure out is what is the grand total area. So we're gonna add those together. So this is what I wanna see you write. A sub T for the total area. Total area is gonna be the area of the rectangle plus the area of the triangle. Substituting what we know, so this will be 120 square yards plus 25 square yards, and that gives us a grand total of 145 square yards. And you just found the area of your first composite figure. Let's take a look at another type of composite figure and another method that we might be able to use. So here we're going to use what's called the takeaway method. I made up that name for that method because it just makes the most sense for what we are about to do. So as you can see, we like almost have a rectangular shape, but we have a divot that's in the shape of a triangle. So what we are going to do is we are going to compute the area of the rectangle, and then we are going to take away the area of the triangle. So here's how this method works. We're gonna fill in the rest of the composite figure and then subtract the missing portion away. So that 3 millimeters is for the arrow going up and down. So that 3 millimeters is going to be the height. So just please be aware of that. That's my perpendicular symbol. So let's find the area of the large rectangle first. So we know it's going to be length times width. So this is going to be 9.3 millimeters times 7.8 millimeters. All right, and on the side here, I'm going to do some scratch work off to the side so it doesn't bleed into my nice and neat, clear work. So I have 9.3 times 7.8. Let's go ahead and multiply this through. 24, that's 72, 74, 0 placeholder, 21, 63 plus 2 is 65. Boom, add that up. All right, and remember, when you're multiplying decimals, you count up your decimal places. I have 1, 2, so my decimal place will go 1, 2. So my answer is 72.54 square millimeters. Okay, so that would be the entire rectangle. Now we need to figure out what the area of this triangle would be, and then we will subtract it because you see how it's white? That means it's missing, so we'll subtract it away. So let's find the area of the triangle now. So again, thinking about rectangles, we know that opposite sides are equal. So if this is 7.8, then this up here, the base is going to be 7.8 millimeters, and the 3 millimeters is that height with that line with both arrows. So we know the area of a triangle is 1/2 times base times height. We're going to substitute in, so this is 1/2 times 7.8 millimeters times 3 millimeters, okay? Half of 7.8, well, let's see, half of 7 is 3.5, and then half of 0.8 is 0.4, so I'm going to add those together and I get 3.9. So that's 3.9 millimeters times 3 millimeters, and again, I'm just going to do some scratch work over here. So I have 3.9 times 3, 27, 9 plus 2 is 11, 1 decimal place. All right, 11.7. 11.7 millimeters, square millimeters, because millimeters times millimeters gives you millimeters to the second power. Okay, so now our total area. So we're going to write area sub T. The total area is going to be the area of the rectangle minus the area of the triangle. So this is going to be 72.54 minus 11.7, okay? Yet again, I'm gonna find some space off to the side to do my scratch work. So I have 72.54 minus 11.7. You line the decimals up, add a 0 placeholder. I need to regroup. 8.06. So my final answer is 60.84 square millimeters would be the entire area of this strange shape that had the triangular divot in it. I'm gonna go ahead and do the second part on a separate video because it's the shorter the videos, the easier it is for me to upload. So tune in for the next problems on the back side in the next video.